How's it going, everybody? In this video, we're going to go ahead and actually dive into the verification section of option C. We really haven't had to do that for option A or option B because it was fairly obvious as to what was happening. And during the packet walks, it was obvious when things would pop up and things like that. Option C is a little bit different because now we have a scenario where we have a single label switch path going from end to end, and we have a number of different ways that you can implement that. Now, when we did the IGP redistribution from BGP into IGP, we only had we had a two-label stack, and the two-label stack got us from the ingress PE to the router that was connected to the egress PE on the other autonomous system. So it was a two-label stack up to that point. So it would be a two-label stack from here to here. So it'd be two labels from the ingress PE here to the egress ASBR to the ingress ASBR to the PE, or the provider core router that connects to the egress PE. It'll be two labels. As soon as it gets to here, the PHP process kicks into play and pops the top label, or exposing the VPN label, and that is sent down to the egress PE as it goes out to the customer. That was fairly obvious for most people. The problem that a lot of folks run into is, how do you account for a three-label stack when you're going from one provider to another? How does that come into play? And why is there a three-label stack? So let's go ahead and actually break down those details right now and walk through what's actually happening. So I'm going to go ahead and pull up the command line, and I'm going to go do a trace route from 19 to 25. So if I do a show IP route, we're going to do a trace route to 10.1.25.25, sourcing from loopback 1 numerically. And we're going to have a three-label stack. So we have a three-label stack here, we have a three-label stack here, we have a two-label stack here. Now, the reason why we have the additional labels in here is we have to account for what we're trying to accomplish. So let's actually look at CSR1 and try to understand why we have the labels that we have. So if we look at CSR1, for example, because these are ingress PE router, if we do a show MPLS forwarding table for 1.0.0.11, we're going to see that the outgoing label is 34 or 24,018. Okay, we go back to router 19, and you'll see 24,018. Right? The 24,018 is actually the LDP label that's being used to get from the ingress PE to the next hop, which is going to get us to XRV9. Then from XRV9, we log into him. We do a show MPLS forwarding table for the prefix of 1.0.0.11/32, and we see that the outgoing label is going to be 34. So when we look back at router 19, we can see that the second label value here is 34. Excuse me. So it's 34. That gets us from. So this first one here is 24,018. That gets us from here to here. So the first label. The second label here, which is 34, gets us from here to here. Then when we get to CSR4, you notice how we go from this is a three label, this is three labels, this is two. So the LDP label gets popped, so PHP kicks into play right here, and then you go down to a two label path for 24,023. Now you might ask, okay, where's 24,023 come into play? Well, we go back to router XRV11. You notice 24,003 is coming in across the wire. If we look back at CSR1 and we do a show BGP IPv4 unicast labels, you're going to see for any traffic used to get to router 8, which happens to be connected to CSR8, or which is router 25 here, you'll notice that label 24,023 is used. This label is a BGP label used to get us from route CSR1 here through XRB9, CSR4, XRB11, across here, down the path to here. So that's basically where that comes in. And then that's 24,023. Now, if we were to go back and take a look at this on the way that the connectivity pops off, let's look at the label value. So we do a show BGP, VPN v4, unicast, all, and we look at the traffic for router 25. So we look at this particular prefix right here. We're going to receive the label 38. That's going to be the label that we use to get to CSR8. If we go back to 19, we can see the label 38 is used end-to-end. So this label right here, this first label, which is going to be our top label, gets us, which is LDP. So we're going to go ahead and grab my pen tool again. I'm going to switch the color to yellow. So this guy right here is LDP. Actually, let's from the stack. So 24,018 is LDP. The next label up is 24,023. This is going to be BGP or IPv4. And then the last one is going to be 38, which is BGP, VPN, v4. That's why we have a 3-label stack. So these two are used to get us to the egress PE router, or I'm sorry, egress ASBR. This label here is used to get us from the ingress PE to the egress PE, and then this label here is the label that's associated by the ingress ASBR or the ingress PE on the other end. So when router 25 sends a route to CSR8, CSR8 allocated label 38 for that. And because the fact that the connectivity is in play to allow CSR1 to learn about CSR8's routes, that's how it ends up knowing how to get to where it's got to go. So that's basically what ends up happening. So just to recap that one more time, we have this right here is the VPN label, this right here is the BGP IPv4 label, and this one right here is the LDP label. Now you'll notice that it only does that for the incoming, for the first couple of hops here in the core, and then once it gets to the ASBR connection, which is right here, hops 4 and 5, once it gets to here, we notice we go down to a 2-label stack. That's because when we get to here, we are going to, there's no ingress PE router to associate a 3rd label stack, or to insert a 3rd label into the stack in order for us to need to get to where we got to go. Because if we were to look at it from the perspective of, I'll go ahead and clear the screen, XRB12 for example, and log in and do a show BGP VPN v4 unicast all, or unicast, we're going to learn 25. So if we were to do RD of 2:1 for this specific prefix, that's going to be our VPN label right here, which is 38. And if we do a show BGP IPv4 unicast labels, we are going to get this label here, 24,021. That's BGP. I don't need BGP inside of my core. I need show BGP VPN v4 unicast, and show MPLS forwarding table for the prefix of 2.0.0.8/32, and I'm going to use these label values to get to where I got to go. But you'll notice that when we're on 19, when we get to here, we use label 21 to jump across from 11 to 12. So when we look at back at 12 and we look up here, we know that when we receive in, let's look at the whole forwarding table real quick. When we receive 12 in, was it 12 or is it 21? when we receive, right, so when we receive 21, let's go back to 12 now. When we receive 21, that is going to, when 21 is received inbound, because XRB11 is going to use show BGP IPv4 unicast labels. We're not going to have 21 here. So if we do a show BGP VPN v4 unicast, or no, sorry, that's going to be show to get out to, okay, so right here, sorry, I was looking at the local label, not the receive label. So what's going to end up happening is we get 21. 21 is going to be used to get from 11 to 12, because that's what 12 allocated right here. So you're going to get 11's going to use 21. Trying to find where 21 got allocated here. Show BGP IPv4 unicast labels. Okay, right here. So 21 was allocated for traffic going to CSR 8. So when traffic comes in from CSR 1 and eventually gets to XRB11, XRB11 received label 24,021 from XRB12 saying, okay, in order to send traffic across the link between XRB11 and XRB12, I want you to go ahead and use label 24,021, which we look right here. That's what label shows up right here. And then when we jump across, this is a one label stack. So from a transport label, we have multiple labels throughout the entire path. And then when we get to XRB12, we look at the show MPLS forwarding table for the prefix of 2.0.0.8/32, and we use the egress label 24,018, which if we look back here on 19, we can see 24,018 is used to get me to XRB14, which, or in this case here 15, which drops me off on CSR 8. So that's the process. So you use an BGP route, BGP labels from the ASBR connection to get a jump across to the remote ASBR, from the remote ASBR to the remote egress PE router. So it's LDP here to get you to the egress ASBR. Then you use IPv4 BGP labels to get you to the ingress remote ASBR. And then from there, you use BGP labels to get you, or in this case here, it's LDP labels to get you from 12 or the ingress remote ASBR to the remote egress provider edge router. So how important is it to be able to nail this down? It's pretty important, because if there's a problem in the forwarding table somewhere along the lines, you have to understand the stacks, and that's going to be really, really important as you start diving into this more deeply. So those are the main factors here. So that's where, and then when you start taking a look at the different capabilities, for example, pardon the cough, the traffic engineering that comes into play. Again, you're not tying that to VPN v4 connectivity. You're tying that to IPv4 labeled unicast between the ASBRs to allow BGP-based traffic engineering to take effect. So that's why I think in a large-scale deployment, IPv4 labeled unicast makes more sense for service providers that need to rely on traffic engineering when there's lots of peerings, where redistributing traffic into the IGP to just have LDP allocate a label doesn't make any sense. So just so everybody's on the same page here, if we were to dissect this one more time, just so everybody's on the same page, if we were to look at this, we have from a label stack, we have LDP, we have IPv4 BGP, and then we have VPN v4 BGP. Same thing with this one. So this is 1, this is 2. The third label stack, we go The second label stack is all this. The third hop, in this case here, is going to be popping LDP. So this will just be IPv4 BGP and VPN v4 BGP. The fourth label stack, this one here, will be same as this one. And then when we get down to getting into XRV12 to get to, so 5, 6, actually, sorry, 3, let me actually back this up a little bit. 4 is the same one in here. No, sorry, that's not correct. 3 is still in play. Oh, I'm sorry, I've got this numbered wrong. VPN v4. Let me actually erase this. So let's relabel this. This is 2. This is 2 and 3 is this one right here. Since you have a 3 label stack, this is 4, where we go down to a 2 label stack right here. This one here is going to be 5 is going to be a swapping of because this is a new LSP. So this technically is a new this one here, these first ones here, so this guy, and this guy is a label switch path for BGP IPv4, and then that terminates on XRV11. And then we set up a new connection we swap to a different label. So technically 5, 4 and 5 are this. And then when we get to 6, which is swapping to a different label, we are now back to LDP / VPN v4 BGP for 6 and 7. And then on 8, we are doing just VPN v4 BGP, and then obviously with hop 9, there's no process happening at all there. But see, being able to disseminate what's actually happening here, LDP IPv4 VPN v4, LDP IPv4 VPN v4. Then we have just IPv4 VPN v4, IPv4 VPN v4, LDP VPN v4, LDP VPN v4, VPN v4. These are the steps that you need to be able to pick apart and stuff like that. Now, why did I show you that on the command line as well as showing you in the trace route? So you have a visual representation. So it'd be easy to correlate in terms of what's actually going on. So that's why the details are just really important. It's to understand how all this stuff comes into play, and knowing what goes where and why it goes there is really important. Because if you need to troubleshoot something, that's how you're going to go about troubleshooting it. In the event that you need to troubleshoot it. If you don't need to troubleshoot it, great. Where I've done this quite a few times and I'm comfortable with the logic. But if you're not comfortable with VPN v4, or I should say labeled unicast, that could be a problem. You're definitely going to want to get comfortable with it. So there was a period of time where I was like, I wouldn't even touch it. But then I forced myself to go through it. I was like, oh, this is actually really, really easy. It actually makes more sense to do that than it does to do BGP to IGP redistribution to enable label binding via LDP. Especially if you have a lot of routes, you don't give it any flexibility with the routing. Unless you were to do something internally in the core to choose one path over another. But it still doesn't make sense to use IGP. Because IGP traffic engineering is it's not there yet. So I don't think it ever will be. But that just gives you a couple of examples of what I mean. So with that being said, that's basically what I wanted to go over with you and break down. Hopefully that all makes sense. And you guys can use this breakdown to understand the traffic flows and stuff like that. So until next time, guys, thanks so much for stopping by, and we'll catch you in the next one.